Lecture 3 of Unit 1 is very content heavy, so I've divided this lecture into smaller videos. Our first lecture related to arithmetic operations is going to kind of relate back to math, but there's a little bit of a twist related to the Java language, and so it's important that you pay attention to that twist. So let's talk about what an expression is. An expression is a value or an operation that computes a value. So the most simplest expression is a literal value like 42. But we could also have expressions that use operators and evaluate to a simpler expression. So just like you are used to in math class, we have addition, subtraction, multiplication denoted by the asterisk symbol, division denoted by a /, and then an operator that you may or may not be familiar with, the remainder operator, modulus. But when your program is running, the expressions are evaluated. So 1 plus 1 evaluates to 2. 3 times 4 is 12, so this statement would print 12. But what if I actually wanted to print the text 3 times 4? Remember, if I actually want to print the literal text, you put that inside quotation marks. And so in here, I would have to include it in quotation marks, and then it would no longer evaluate 3 times 4. It would just display 3 asterisk 4. So let's talk about two operators having to deal with integers. So let's talk about integer division. It's important that you understand in Java, if I take an integer and I divide it by an integer, I'm always going to get an integer. Even if in Mathland you get a decimal, we end up having to truncate or drop the decimal portion. So for example here, 14 divided by 4, if I go old school and I do 14 divided by 4, 4 goes into 14 3 times evenly, and I end up with a remainder of 2. I don't really care what the remainder is. The answer to this is that integer portion. And so 14 divided by 4 is just 3. It's not 3.5, it's just 3 because each of those are integers. Likewise here, 45 divided by 10 is not 4.5, it's just 4. We drop the 0.5. An integer divided by an integer can only result in an integer. And then 32 divided by 5 is going to be 6, not 6 point something, not 6 remainder something, it's just going to be the 6, the integer part of your answer. Here, 84 divided by 10, 84 divided by 10, 10 goes into 84 8 times. Yes, there's a remainder, but we don't care about the remainder when we're doing integer division. 156 divided by 100, 100 goes into 156 1 times evenly. I don't care about the 56 that's left over. I don't write 1.56, I just write 1. It's just the integer portion of the answer. Now, in math, you are not allowed to divide by 0. In computer science, you're not going to be able to divide by 0. What happens if I come here and I divide by 0, you'll notice that I'm going to get an exception. When I'm running, it's going to say it's an arithmetic exception because of division by 0, and it's going to tell me that it occurred on line 3. You are not allowed to divide by 0 in math class. You're not allowed to divide by 0 in your programs. So in this case, it's going to give you an arithmetic exception. Now it seems a little trivial right now, like why would I divide by 0 if I know I can't? But in reality, if you're dealing with variables at one point or another, and those variables have the opportunity to change value, if you happen to get a value of 0 and use that in division, you'll get an exception unless you handle it. And we'll talk about how you handle those in future units. So that's integer division. Now let's talk about an operator that may or may not be new, and this looks like a percent symbol. It's the modulus operator, and in this operator, we only care about what's left over. We care about the remainder from integer division. So with the integer division, division just cares about the whole number part. Here we actually care about the remainder portion of it. So using some of those similar examples, let's see how this works. So if I do 14 divided by 4, we get a 3 remainder 2 using old school methods. So with integer division, I'd care about the 3. With modulus, I care about the remainder portion, so this is going to be a remainder of 2. And then with 45 mod 10, so I just say mod. When I take 45 and I divide by 10, it goes in evenly 4 times, and then I have a remainder of 5. So the answer to 45 modulus 10 is going to be the 5. It's that remainder piece if I go old school with my division. And then with 32 mod 5, if I take 32 divided by 5 and do old school division, I get a remainder of 2, so that is what I put here. Alright, so just keep doing your old school division and see what the remainder portion is. We don't care about the decimals. We don't deal with decimals when it's just an integer and an integer. And so if I continue doing my old school division, I'll see here my remainder is 4. And I'm doing the work, but you might be able to just figure that out on your own. But realize that your remainder is never going to be equal to or greater than this value here. Otherwise, you could fit it in more. So this will be a remainder of 56, so this will be 56. And just as I can't divide by 0, I can't get a remainder of mod 0, and so this will give me an arithmetic exception just like the previous one. And then let's add some new ones and see how these work. So 2 mod 2, so if I do 2 divided by 2, that's a 1 with a remainder of 0. And so you are allowed to get a 0 as your remainder. If I do 8 mod 10, it's important that you put 8 inside the little division house. And you'll see here I get 8, so that's the exception. If this is smaller than this, then it'll be 8, but here 0 mod 5, 0 divided by 5, I get a remainder of 0. So this will be 0. Okay? Alright. Let's do one more. Now this is an example of something that is probably not going to be in the AP exam, but how do I deal with integers that have negative numbers? Well, I'm just going to first worry about doing the normal remainder. And so I'll get a remainder of 1. So all of these are going to have something to do with 1 in my answer. Now how do I know if it's positive or negative? It doesn't follow the same rules as it does with like if one of my numbers is negative, then the answer is negative. It actually has to do with the leading number, and only the leading number will determine this. So if your leading number is positive, your remainder will be positive. If your leading number is negative, your remainder will be negative, regardless of what the second number is. Alright, so two operators, integer division, and then the modulus operator. They kind of come together to make a complete set, but it takes a little getting used to.